Next up, we have Joe Wonsil, who will be showing us a language-agnostic debugger with some additional features.
Thank you.
Okay, I guess you can step down now.
Okay, thank you. Hello, everyone. I'm Joe Wonsil. Although before I start, I would like to make some quick acknowledgments. I would like to give a very big thank you to the computer science professors here, because quite literally, I would not be here without them. So thank you. And then additionally, I would like to thank the people that I worked with this summer in my research, because I also wouldn't have done this project without them. So thank you to them. And thank you to everyone here. I know some of you actually have to be here, but thank you for listening to what I'm saying. So I'm doing a language agnostic provenance debugger. Undoubtedly, the first time I ever tell this to anyone, they say, what's provenance? So provenance, or I'm talking about specifically digital provenance, because if you just Google it, you're probably going to find something about art. So just as a warning. So specifically, digital provenance can be defined as the record of a history of a program's execution. So what that means, if we think about programming as more of like cooking in your kitchen, your data is probably your ingredients, your recipe, and the steps you have to take to actually make your food. That would be like your program. But then if you were to actually start executing it and making your food, if there's somebody behind you writing everything that you do down in excruciating detail, that is what digital provenance is. So if you think about maybe your ingredients, your file version, what data is going in and out of your program, your ingredients, all that's being recorded if you are collecting provenance. So I mentioned a program. I'm actually talking about programs and scripts here. So there is some differences, but for this presentation, I'm going to be using the two terms synonymously. So my debugger is based off of provenance data, which makes it able to do a lot of really cool things that regular debuggers can't. For example, it's language agnostic, so you can use it with multiple languages. Typically, C, C++ uses the GDB debugger if you're talking about like command line debuggers, or under the hood if you're talking about the GUI. Python, PDB, and R has to be different every single time, so they use browse and debug. But every single one of these you actually interface with the exact same way. So you'll stop maybe on a certain line because you think something's going wrong there, and then you'll type N or you'll write out the word next and it'll advance one line. You can step in and out of functions, and then you can just continue running your program if you want. So even though these are all very different languages, typically for different purposes, the fact that their debuggers are so similar sort of lends to the idea that there's enough similarities between them that if you were able to generate an abstraction layer between the language and the debugger, you might actually be able to use one debugger for multiple languages. So I believe that abstraction layer is provenance. So I wrote a debugger called ProvDB that uses provenance as an abstraction layer between different languages. So if you run a program or a script and you have provenance collected from that execution, you can use a single debugger, no matter what the language is, to debug that script, find errors, see what's going on with your variables, see where the flow of control is going. And this is only possible because of provenance, but it also gives a few more cool features that you can do. So there are a few provenance collection tools out there right now. Unfortunately, these features aren't baked into these languages. It'd be really cool if they were, but your programs would probably run a little bit slower, so you don't want that. So for R, there's R data tracker is a provenance collection tool. And then for Python, there's one called no workflow. And R writes out provenance in a format called prov.json, which is just a standard that is extended from a W3C standard. And then no workflow stores their provenance in a SQLite database hidden in a local directory. But there is a tool that exists that, when run on their database, will actually export their provenance to the same prov.json that our data tracker exports theirs to. And this is what gives us that exact same provenance in between the languages and the debugger, because the provenance is stored in the exact same way. For C, there actually is someone working on making provenance collection tool right now. I'm not exactly connected to that project, so I don't know what format that's in. But eventually, we may have ProvDB might work on C as well. So to actually accomplish this, this is how my thesis was structured. Since it's stored in JSON, I had to actually load it into memory, and so I wrote a parser that would do that. I didn't rewrite a JSON parser. I definitely used a pre-existing parser. However, I had to manipulate some of the JSON a little bit, so there were comments in there. I didn't need that. There were prefixes attached to certain nodes in the JSON, and I had to remove those because otherwise it would show up in your code when you were debugging things, and you'd say, I didn't write this line, but you would be correct. And so I had to remove that. And then using the parser, the provenance is stored as like a graph structure with nodes and edges. And so I actually wrote a class that would input that provenance data into a graph in memory. It doesn't visualize it, it's just in memory. And then this allows me to traverse through the program and then find out information about the script. So I'm using those two classes that I wrote to do that. I wrote a suite of debugging functions that would reveal information about your script to you as you're debugging it. This can be like lineage of your variables. I'll go into it a little bit more later. But typically, when you're debugging something, you shouldn't have to like import a library and then like write more functions into your code to debug it. So I wrote a third-party, a standalone piece of software that uses these functions that you can run on your provenance to debug your scripts. And it's just a command line interface similar to GDB, PDB, or if you're at all familiar with the debugging functions in R, it's the exact same as those two. However, I did make sure that when I wrote this, I wrote a browsing API first. So the command line browser, or the command line debugger that I wrote, actually gets all its information from the browsing API. So this way, if somebody, me or somebody else, came by and wanted to make a GUI instead of a command line debugger, they could using the exact same functions. It's not integrated too directly into the back end of things. So that way I can make changes in the back end that won't affect the interfaces, and sort of vice versa as well. So the way, I've talked about the graph a lot, and that's a bit of an abstract idea sometimes. So to actually illustrate exactly what I mean, at the bottom here, this is an example 3-line R script, and this is the corresponding provenance actually visualized. So this is the graph that exists in memory when it's loaded into my debugger, visualized. And so you can see that the name of it is at the very top, that's the start, and then there's different nodes and different edges. So first we have procedure nodes, and these are nodes that correspond to expressions that have been evaluated in your program. Typically, that is a single line of code, if you want to think about it in like the most simplest terms. But anytime essentially something is evaluated by an interpreter, say, that would be an expression that's evaluated. But as well as when a script starts or some sort of control structure starts, those are all going to be considered procedure nodes. Then we have data nodes, and these are typically variables. We also have like file names, or not file name, but like the file itself, that would be a data node. And so here I just have like all the names recorded, but in the provenance itself, a data node would have the name of the variable, the value, if it has any dimensions, those, and any sort of other information. So for example, data nodes for files will have a hash associated with it. So that way you know if you're using the same file from a previous execution on your current execution, and you'll know if they've changed. Moving on from nodes to edges, we have procedure to data edges. These are referring to the line where a variable was created. So if you declare the variable stuff on line 1 and you have your data node called stuff, you can trace back the procedure to data edge, and you'll see on line 1 I declared the variable stuff. And then sort of the opposite, data to procedure edge, if you already have this variable called stuff and you want to know later on in your script where you've used it, you can follow its data to procedure edges, and it will show you every single procedure node where that variable was used. So this information, tracing passed through the graph, allows you to actually like see connections between all your variables. So if you change this one, then you'll know what's affected later on down the line. Or if this one has changed and you don't know why it's changed, you can check to see what might have had an effect on it previously. So the features of my debugger, it has basic traversal, just like a regular debugger like GDB, PDB. It also has variable checking, so this is pretty standard in debuggers. You can print out the value of your different variables. What I was just talking about, lineage, so you can check the connections between your variables, as well as checking extra information about any sort of runtime errors you might have. So just for basic traversal, This is a Python script, and I'm advancing using my debugger forward. But then because I'm using provenance information, the execution of the program has already happened once. And when it already happened, that's when the provenance was collected. So since I'm essentially doing a post-mortem debugging, I can actually back up through my code as well. So you can step forward and backward through your script. And you can see the values change as you go, and you can see where the flow of control goes. So this is in Python, but just to demonstrate that you can use this on multiple languages, this is the exact same thing in R with the exact same debugger. So you can move forward, you can move backward, and you'll be able to see what's happening in script as they execute. And so you can also check, as you're doing that, what the values of each variable has. So in this example R script, I have foo, bar, and bat. I have two numbers and then the string hello world. So if I print out the value of bat, it'll say its value was hello world, which is a character vector. Or you could see that foo is a number 5, bar was initialized with foo times 6, which is 30. So in the lineage information, this is found by tracing that graph that I mentioned earlier. So if you declare a variable called foo that's just 10 and you ask for its lineage, it's just going to tell you that foo is declared on line 3. But if you have the value bar and that was initialized using foo and you ask for its lineage, it'll tell you that it was initialized on line 5, but it's also dependent on foo's value. And then the same thing, that's a direct connection, but it'll also show you indirect connections. So bat uses bar, but that uses foo. So if you ask for the lineage of bat, it will show you every single one of those things. So then error tracing, I have to throw a nerd joke in here because this is a computer science thesis. Everyone here knows Stack Overflow. So what my debugger does is if you have a runtime error during your execution of your program, it'll collect what the message was, and you can ask for it, where it was, what it was, and it will tell you where it was generated and what the message was. But I also am a firm believer that you should be able to be a little independent, and when you're writing your code, and if you have an error, you should be able to have the know-how to look it up online and find out, are other people also encountering this error? How are they finding solutions? And so to facilitate that, part of my debugger, if you choose to use it, if you have a runtime error in your program, you can ask the debugger to query similar error messages on Stack Overflow for you, and then it will print top 5 options for you in your terminal, and you can choose one of them, and if you do, then it will open up that exact page in Stack Overflow for you. And then you can see, is this the exact same error I have? You can see if maybe you can choose a different one, and then maybe their solution is what you need, and you can try and implement that. So working on this project has been a roller coaster from the very start. But just to kind of start internally, less than a year ago, there's no way I would have thought that I'd be doing something like computer science research. I always thought I'd be doing projects for industry or something. And that changed very quickly. I got very lucky with that, with a project that I worked on over the summer. I got to work with a group of people who introduced me to provenance. In the very beginning, the people who actually wrote our data tracker, the provenance collection tool for R. And by working on that project, I got involved in a lot of what computer science research is. And I realized that I might actually be capable of doing this, and I might even want to continue doing this after Carthage. So over the summer, I started looking into graduate schools, and I'm going to be continuing doing computer science research, actually working with some of the same people I worked with this last summer at my research experience at the University of British Columbia. So switching away from internal reflections now. This project has helped me stay in contact with people that would help me get into graduate school, and ultimately did. So I was able to really keep a good connection with a lot of really awesome people going. And then working with some of these languages like R and Python, they are very different. R is made for statisticians, so a lot of the general sort of ideas that we hold about software development and how programming should use, R just throws out the window, because they're you shouldn't have to do that. Every other languages uses equals to assign something. Yeah, we're not going to. Why would you do that? That doesn't make any sense. And Python is used for data science similar to R, but as I'm sure you all know, it's a much more diverse language. It's used for a lot more other things as well. And it shows in the language. So if you want to do something like what you do with R, you have to import a bunch of libraries, and it's much different. So learning about these two different paradigms sort of simultaneously, while also like developing software, was a little mind-bending sometimes. I kind of just had to like sit down and say, okay, what am I actually doing right now? How can I solve these problems? All sorts of things like that. And it took time. So I'm actually going to jump off what Charles said a little bit about don't think that it's a race, because sometimes you just need this like slow burn, and if you try and get right into it and like finish it as fast as you can, you're definitely going to burn yourself out, and you're going to like confuse yourself. As Professor Kowalowicz likes to say with his juggling of the balls, you will drop them very quickly, very quickly. And then also mention on documentation, I think every person who's going to present today is going to be lying if they said that there's not something they have to say about documentation. So definitely read it if there is documentation. But just as like an extra thing, sometimes there's not documentation. For example, I was writing this entire debugger in Python in a certain version, and then the provenance collection tool for Python, their most stable version is just a little bit not up to where I am, but it turns out that they have an alpha version for the version of Python that I was writing this in, but there's zero documentation, and it's also the next version, there's a lot of versioning going on, of their own tool, and so everything is completely different. The way they stored the database is completely different, but because it's still the alpha version, there's no stable release yet, they haven't released any documentation on how it works. So you'll encounter these problems where you have to sit down and say, all right, I'm either going to have to spend possibly a month trying to figure out how this SQLite database is formatted. There's 30 different tables. What do they all mean? They're all connecting to each other. Or I can use the older version that's probably going to go obsolete very soon, but at least I can present my thesis. And so you kind of have to weigh these options. What are you going to do? I chose the one where I can present my thesis, as you can see, and actually have something that works. But yeah, so documentation is incredibly important. And ultimately, this project was fascinating to me because I'm so, I guess the word would be, I think debugging is very important. I think we should all agree on that one. So having something that actually contributes to that was just incredible. Are there any questions?
So do you think that at any point, there's going to be a point where we switch away from the specific debuggers like GDB or PDB and then use a agnostic debugger like you kind of been researching?
No.
Or repeat the question.
Thank you. Yes. So the question was, do I think there's going to be any point where you might actually switch away from traditional debuggers to something like mine? My answer is no. I think the furthest I could see it going is actually like a hybrid. Because this is a postmortem debugger, I do think there are people who are certainly going to want to have a debugger that maybe it doesn't let them back up while they're going through the lines, but they would want to see things happen live. Some programs, like some data science programs, are probably going to be so time intensive that actually adding a provenance collection tool on top of that is going to slow it down so much that it might be not usable. But what I could see is like a hybrid of it's collecting provenance as you go, and then if you decide that you do want to maybe like back up or like check some other values or check lineage, it might be happening at the same time as you're debugging normally. And I actually think that as like a sort of future work thing, that would be something that I would love to try and do. I don't know if that's in my future or not. As a standalone debugger, like forgetting hybrid with a standard debugger, there's still plenty of things that I could implement with just this. So there's a lot of paths you could go down. Yes.
Is this debugging specific to data science, or is there a particular type of problem that this debugging is more useful for than, say, traditional debugging?
Mm-hmm. So the question was, is this debugger specific for data science, or is it trying to solve a specific problem? Currently, I would say I think it probably works better for data science than software development, just because of what it's actually capable of doing right now. But theoretically, it would be anything This came out of a project that was specific for data science because provenance can also help scientific reproducibility. There are a lot of issues in science right now where people can't reproduce data analyses, even given the same data as a study had. And so a lot of things can contribute to that, including just the operating system you're on, the versions of the libraries you're using. And if you have all that information, or if you can literally recreate the execution as it happened, you can see how people are finding their results. And so that's where the idea of like our data tracker, that's what it came out of. And so this was sort of like a next evolution. I worked on a similar thing over the summer for just R, and this was kind of like the next step. Can we like generalize it a little bit more since provenance can act as a layer of abstraction? Does that answer your question?
Yes, but I have another one.
Okay.
That's about documentation.
Yes.
And I apologize for asking this, but you have a tool. Did you write documentation for your debugger?
Yes. It is not finished. So the one I did over the summer, the one for R, that one is totally done. So if you want to know what it will look like, you can check out that GitHub repository, and I wrote an entire wiki for it. Not just a README, an entire wiki. And this would eventually theoretically have the same thing. I just needed to finish it to the point where I could present. Thank you.